Hello guys, today I'd like to show you how to tune the Minima bias setting on the KISS mixer so that if you don't have a spectrum analyzer you can see what is the effect of the bias on the output signal and what it looks like on an oscilloscope. So hopefully you can do the adjustment even if you're just following at home and don't have the same equipment. So if you're on the mailing list, you know that I've been struggling to get my mixers working. This one is a replica of the KISS mixer on a little board, and it was not working for the longest time. And my problem was really simple. Joe Ritchie pointed out what my problem was, so thank you very much, Joe. I mean, it gave me a way to find out what the problem was. I had a broken wire here in that little connection between the transformer and the pad. One of the wire was cut short of the pad, and so that's where the big asymmetry came from my previous video. So I didn't realize it was an asymmetry, but he did. And he suggested just disconnecting the transformer from the drains of the transistors and connecting one to ground and looking at the output, and then connecting the other one to ground and looking at the output. And sure enough, I did it for the first one, it worked perfectly, and then I tried the second one and then I had nothing on the output, and that's when I realized that I had a disconnect here. So that's a nice little trick, I think, if you're stuck with your Minima. Anyway, it's working now, so let's look at my setup one more time. Same setup I had last time. So I'm injecting two signal. This is the intermediate frequency. This is the local oscillator, and I'm injecting from a function generator here. The local oscillator on channel 2 is 34 megahertz at plus 10 dBm. And on channel 1, I have the intermediate frequency, 20 megahertz minus 20 dB. And so the resulting product will be at 14 megahertz, 20 meter band. And we're trying to get that maximum mixing product while still minimizing the IF and the LO in the output of the Minima. So let's look what this looks like on the spectrum analyzer right now. So this is not adjusted yet, and we can see that I have the mixing product at 14 megahertz, which right now is at minus 37 dB. I have my IF and I have my LO, and here on the scope I'm showing you the drain and the gate of one of the JFETs. So if you look here, one of my probe is connected to the gate here, and here is the drain of the JFET. And they're both in DC mode because I want to look at the effect of the bias here, and they're both times 10. So let's look at what happens when I play with the bias, and you can see the current value of the bias here on the fluke. So as I increase the bias, I can see that my signal, and if you look at the spectrum analyzer, and I'll show you closer, but it gets better and better and better. And then here I'm reaching a maximal. If I keep increasing, just starts decreasing after a while, and then the mixing product is like completely nulled out in the output. So let's look at this again. This is 5-volt bias going down. This is my good zone, and this is when it gets bad. Not as good, we'll say. So now let's try to maximize the mixing product. And so I'm at minus 34 now, minus 30, minus 29, and that's about as good as it gets for me. So right now, I hope you can read that. The let me try to make sure you can read that. So right now you can see that the mixing products is at minus 28, 29 dBm. So that's 9 dB conversion loss, which is not too bad, at least much better than what I was getting before. If we look at the IF, it's at minus 40 dBm right now, so that's about 20 dB suppression, which is pretty good. And the LO was at plus 10 and now is at minus 12, so that's 22, 23 dB suppression, which is not amazing, but the LO is really close to the IF on my little board here, and I'm hoping this will get a little better in the real Minima. So again, when you're adjusting it, starting from 0, the part where it gets interesting is around here. That's when we have our maximum value at about 1.7 volt on the bias, and then I can keep increasing a little bit. Can go up to maybe 3 volts, something like that. I'm still at minus 30 dBm on the mixing product output. Now if I keep increasing here, it starts decreasing, so you can see on the scope I'm getting far. The drain is getting far from the gate, and the mixing product starts going down, and it keeps going down. So if you have a scope, you can look for this point here. That's really where you want to be. That's where you'll get the best mixing product. And if you just have a multimeter, you could also do it. You can just aim for that area around here between 1.7 and 3 volts. So I guess 2.3 volt, which was the value recommended on the mailing list, is really a very good value, and fine-tuning it to be a few hundreds millivolt above or below doesn't seem to make such a big difference. So I would say the correct area is actually pretty wide. So that's it, just a short video to show you that. And thanks everyone who helped me fix my problem. I learned a lot here. Thank you guys.